Here we have a SAT math problem. Okay, let's go to the question. In an isosceles triangle with a height 10 and a base 10, a square is inscribed with side x along the base of the triangle as shown above. What is the area of the square? Okay, now my aim is to get the value of x because x represents the length of the side of a square. Once we get the value of x, we can multiply the value by itself to get the area of the square. Okay, now we have to get the value of x. Okay, now let me name the vertices for the given triangle. Say this is A and this is B and this is C, and let me say this point is D and this point is E. And the question says ABC is an isosceles triangle. If a triangle is isosceles, two sides must be equal in length. Which two sides must be equal in length? AB and AC, or AB and BC, or AC and BC. Okay, now let's consider the square which has a base along the base of the triangle over here. And also two of the vertices of the square lie on the two sides of the triangle AB and AC. Since the base of the square is along the base of the triangle and these two vertices lie on the two sides of the triangle AB and AC, so the sides AB and AC must be equal in this triangle because ABC is an isosceles triangle. So only if the two sides AB and AC are equal in length, so we'll have these two vertices of the square on the sides AB and AC, otherwise it won't. Okay, now we have concluded in this isosceles triangle, the sides AB and AC must be equal in length. Now let's consider the line segment DE we have inside the triangle. So this line segment is parallel to this one because in a square opposite sides are parallel and equal in length. So clearly this line segment DE is parallel to one of the sides of the triangle BC, that is the base of the triangle. Whenever there is a line segment inside the triangle and also it is parallel to one of the sides of the triangle, then the line segment inside the triangle will create a smaller triangle which is parallel to the original bigger triangle ABC. So now we have an idea that this triangle, the smaller triangle ADE, is similar to the original triangle ABC. Since ABC is an isosceles triangle with AB and AC are equal, then the smaller triangle ADE also must be an isosceles triangle with AD and AE. The two sides are equal because these two triangles are similar. Now let me consider the height which can be drawn between the two equal sides AD and AE in the smaller triangle. So over here. And also let me consider the height which can be drawn between the two equal sides AB and AC in the original triangle ABC. Okay, since these two isosceles triangles are similar, so the ratio of the heights drawn between the equal sides of these two triangles must be equal to the ratio of the bases of the two triangles. Okay, now let me consider the height of the smaller triangle ADE. Actually, the height of the smaller triangle ADE is not known, so first we have to find that. Okay, now let me draw a line segment which represents the height of the smaller triangle ADE. So here this blue color line segment represents the height of the smaller triangle ADE. So we know that this complete height is 10. We know that the length of this part is x. Then what is the length of this line segment? For that we have to subtract this x from this complete length 10. Then I'm getting 10 negative x. So 10 negative x is the height of the smaller triangle ADE. Let me write the height of the smaller triangle. What is the height of the original bigger triangle ABC? That is 10. Which is equal to the ratio of the bases of the two triangles. What is the base of the smaller triangle ADE? That is x. What is the base of the original bigger triangle? That is 10. Let me write over here. Now in this equation, we have to solve for x, which represents the length of the side of a square. Okay, let me multiply both sides of this equation by 10 to get up the denominator 10 on both sides. So this 10 will cancel out. Here this 10 will cancel out. I am getting 10 negative x equals to x. Okay, now let me add x to both sides. When I do so, this negative x, positive x will cancel out. Then I'm getting 10 equals to 2x. Let me divide both sides by 2. When I do so, this 2 will cancel out. 10 divided by 2 is 5 equals to, on the right side we have x. Now I got the value of x, that is 5. Actually, the x represents, as I said earlier, x represents the length of the side of the square. So the length of the side of the square is 5. Okay, now let's find the area of the square. Let me write the stuff over here. Area of the square equals to side times side. That is 5 times 5 which is equal to 25. So the area of the square is 25 square units. So we find 25 in answer choice B. The correct answer choice for this question is B.